Well, hello, I'm Paul Meiman. I'm an associate professor in forest and rangeland stewardship, and I focus on rangeland ecology and management. And early on, I didn't even know that range management, rangeland ecology existed. But my dad worked in natural resources, so I got a solid introduction to natural resources, and I always had a fascination with this. Well, it started out, it was bison interacting with landscapes, and then I got to be more aware of livestock production in rangeland settings, and so that shared interest really came together naturally in rangeland ecology and management. So currently we're working on some really neat projects that get into the details of how animals, mostly domestic, large herbivores, interact with rangeland plants and plant communities. But we also do some work with wild ungulates as well. So one of the most rewarding moments was about a year after I gave a talk at a workshop for land managers and ranchers, and one of the participants came up to me and said, "Do you remember the recommendation you gave me about a year ago at this workshop?" And I said, "Oh yeah, I remember." This individual said, "I drove home from that workshop 2.5 hours telling my neighbor who I was riding with all the reasons why what you recommended wouldn't work. And by the time I got home, I had convinced myself that it might work. I tried it, and it worked beautifully." Well, good afternoon, everybody, and welcome to the FRS seminar. I'm Paul Meiman. I'm an associate professor in rangeland ecology and management in the Department of Forest and Rangeland Stewardship. I've been here since about 2006. And before that, I was an extension range specialist for the University of Wyoming. It was a statewide position based in Lander, and I got an opportunity to work with a lot of folks on the ground. Prior to that, I worked at the county level in extension in Northwest Colorado, and also with the USDA ARS in Boise, Idaho. So throughout my career, I've been really interested in applied research, and I'm going to start out talking about how applied research relates to usable science, and kind of weave that in along with a summary of what some of my current research projects are that are being conducted by my STAR graduate students. You might notice that I changed my title a little bit. So when Ryan and Karina first contacted me about getting on the seminar schedule, I found out the theme was crossing boundaries. And so that title that you probably saw, something about intentional grazing of poisonous plants by livestock, using chemicals to restore native grasslands, and using cattle trampling to improve wetlands, I was thinking, oh yeah, I mean, these people are thinking you're nuts for some of these things you're doing. You're crossing all kinds of boundaries. And so I was really emphasizing that in that title. And then in the last few days, I came up with this one, another application of boundaries. So my graduate students and I joke about the Meiman non-lab. And rather than put non-lab up on my title slide, I decided maybe a little softer way to put that was that my graduate students really, they cross boundaries between labs within our department and even in the college and across campus at the university. So that's my new title. But I'll still talk about the other things, I promise. So if that's what brought you here, worry not. So where we're headed, I'll talk about this idea of usable science and how it does and doesn't relate to applied science, applied research. And then I'll move into those projects that I talked about with the larkspur work that's been conducted primarily by Kevin Jablonski, who just defended his PhD real recently. Jake Korkamp, sitting in the back, is working on this new herbicide called Esplanade or Indaziflam, and its promise for selectively reducing cheatgrass seedling abundance by way of helping us restore some of these native sagebrush grasslands. And then we'll move into Alex Stoneburner's work. She's also in the back right next to Jake. Work with yellow flag iris, which is another exotic invasive plant, but this one really goes after wetlands. And we're looking at the impact of trampling on yellow flag iris. So before getting a little bit more detail on those projects, I wanted to introduce this special issue of Rangelands. It was 2016. All articles in this issue of Rangeland talk about a conference, a workshop that was held in June of 2014 that was called Future Directions in Usable Science. And I was fortunate enough to be one of the participants. There were 40 total participants in this workshop. And I'll kind of key in on what I think kind of the main part of the definition of usable science that came out of that workshop is, and that is the involvement of the intended end users in the research process from start to finish as much as you can. Now, I know a lot of folks in this room appreciate the value of applied research, and we conduct a lot of applied research. But applied research can be conducted in a way where you talk to the end users and you have some level of input on what you think or what they tell you they need for application, and then the researcher kind of runs off and does their project and then brings results back to the end users at the end. And sometimes, and I've been guilty of this myself, we make assumptions about what the end users might need. We say, oh, this would be really valuable stuff, we're going to do this, and then we run to the end users and say, here's this great stuff, go for it, use it, apply it. And they're like, doesn't quite fit my interests or my needs. And so ever since this workshop, I've been trying to involve the end users more and more. So with the 3 projects that I'll talk about, I'll try to highlight how we've been trying to increase the involvement of the end users through more of the research process. So real quick, this issue has one article that's the overview that I'm showing here. Then there's an article that focuses on animals on rangelands, vegetation, soil health, water, and also socioeconomics. And then there's a wrap-up at the end. So take a look at it. It's pretty neat stuff. But I'll move into our first project that Kevin Jablonski has done the recent work on this with gyre larkspur, and really shifting the conversation from avoiding having livestock graze larkspur to active grazing of larkspur or intentional grazing of larkspur by cattle. So Kevin and I pretty much the leads on this. Our end user that's been involved throughout is Joel Vaught, and he's the manager of the Sea Surf Maxwell Ranch that's located north of Fort Collins. This research has been funded by the Colorado Ag Experiment Station throughout, and then recently in the past few years, Joel and Sea Surf have been able to come up with some money to help us with the work. So first, a little background on larkspur. It's often considered one of the most damaging poisonous plants that managers in western rangelands face. There's probably about 300 species in the Delphinium genus across mostly the northern hemisphere, but some other places. In North America, there are 60 or 61 species, but surprisingly, only about 11 of those are responsible for the majority of livestock poisoning problems. Those 11 species are what account for what's listed up here. So annual cattle death loss can be pretty high, 2 to 5%, and then in bad years up to 15% of herd numbers. And if you put a dollar amount on those, it's a significant financial impact in terms of losses, and especially when you consider the age of that estimate and what it probably is now. But more importantly, this has been a persistent problem for over a century, despite a lot of work by researchers, people on the ground, livestock managers, natural resource managers, land managers, and extension and outreach folks. These numbers do not appear to have gone down after a century of work on larkspur. So, what do people do to avoid larkspur losses? The most common strategy is some form of avoidance. Basically, don't let the cattle graze larkspur. And there's a lot of forms of avoidance. I won't go into those. But on the right here is a map that Joel Vaught from the Maxwell Ranch provided us. And he's highlighted in yellow what he considers to be the larkspur pastures. Now, not all land area on this map is in the ranch. So I'll real quick just kind of go around the fence lines of the Maxwell Ranch. And then we have some isolated sections over here. So about half of the land area is highlighted as larkspur pastures. And so avoidance, basically Joel hasn't been grazing these with cattle during the growing season. So for about half the year, half of his land area on the ranch is not used. And that's a huge impediment to management flexibility and opportunities. So we started working on larkspur about almost 10 years ago. And our first projects were another form of avoidance. We were talking to Joel and we thought, gosh, there's got to be something we can do to make some of these larkspur pastures less dangerous and more usable to you. And so our first idea was to increase forb diversity, thinking that forbs would be good competitors with other forbs. So we identified 2 different forb seed mixtures to seed into these plots, to drill into these plots. And then we also thought, well, we might need to open up the community a little bit, reduce the abundance of some of the existing forbs to give our seeded forbs a chance to get started. In a nutshell, it didn't work. We didn't get anything going. So this is just a little bit of what Jesse Schroeder found from his master's work. If you look at the y-axis title there, we're talking about the number of seedlings per 30 square meter plot. And we're less than 30. So we had very little establishment of our seeded forbs. But this actually led to more questions from Joel. He started asking things like I put up here. Does the toxicity of larkspur vary from year to year? We started talking about seasonal patterns in toxicity, and he said, well, do those change from year to year? Really what he was getting at was, can I identify what might be a dangerous season or a dangerous year or a safe season, safe year, early enough in the year that I can start using those pastures? And we said, well, we'll start looking at that. We'll start thinking about it. So basically, this is kind of the shift from avoidance to, you know, how can we start using some of these areas at least somewhat. So we started looking at patterns of toxicity and thinking about moving beyond avoidance. And Kevin and I talked about some recent work by Fred Provenza and colleagues that do a nice job of saying, hey, plants, most of them, the rule is that they're at the same time toxic and nutritious. And so pretty much all plants contain toxins at some level, some types, along with nutrients. And then the other thing is that we know that herbivores actively mix their diet, and in doing so, they mix nutrients and toxins. So Kevin dug into the literature and looked at the data we had for plant size of gyre larkspur at the Maxwell Ranch, and he came up with some estimates of how many plants, basically average size plants that we've been working with, cattle could eat. So LD50, I think everybody in here is pretty familiar with that concept. It's the dose that's lethal to 50% of test animals. So using published estimates of alkaloid concentrations and our plant sizes, Kevin said, gosh, cattle would be able to eat 900 plants a day. That would amount to about 35% of their daily intake if we were going to expect about half of the animals that consume that amount to keel over. The next thing is something you might not be as familiar with, but that's no obvious adverse effect, NOAE. That's more what we're shooting for, okay? I don't want to work with somebody about losing half of their animals to larkspur poisoning. But at no obvious adverse effect, using a similar approach, Kevin figures that cattle could eat 135 to 500 plants per day of larkspur that we're seeing. So it starts to look like, wow, maybe animals can actively graze larkspur. The other thing that we kept coming across was that really not that many animals get sick or die from larkspur in areas where it occurs. Okay? So all of this is thinking, or getting us thinking, that we might be able to move beyond avoidance. And then I can't resist talking about my distant Uncle Frank Robertson. He definitely did not observe or avoid poisonweed, which I'm pretty sure, I've got strong reason to believe, poisonweed is larkspur. Rather, Uncle Frank would, yes, scout ahead and find good forage for his cattle, fill their rumens, and then intentionally bed them on poisonweed for the night, and they would sample a little bit of it. And I was able to come across this story thanks to my Grandma Mary, who took a trip to Montana to visit Uncle Frank and wrote this 60-page handwritten journal. It's just fabulous, and it captured that story along with some others. And so this was about the same time as Kevin and I were thinking about, you know, moving from avoidance to something else. And then I remembered, this is now Kevin's in the scene, he started his program, that Mike Smith at the University of Wyoming had worked with some ranchers near McFadden, Wyoming, who used to be affected a lot by larkspur and death loss in their cattle. So the Sims family made some pretty big changes to their grazing management that involved taking a small number of large pastures, subdividing those so that they have many more smaller pastures and quicker moves. And they didn't do it because of larkspur, but they noticed that after they made that change, they stopped having larkspur problems. And so these bullets are kind of pulled from this fact sheet. These folks suspected that change to their grazing management increased the stock density, so the number of animals per unit area in the pastures, and making it so that every cow ate some larkspur, but basically nobody got too much. And then a quote, the second bullet there, death loss from larkspur has become a thing of the past on the majority of the ranch. And another observation that went along with that was that larkspur plants were smaller and made up a smaller percentage of the vegetation. And so they saw these plants getting smaller and making up less of the total vegetation. So this tracked right along with what we were doing. We were to the point where we wanted to test some ideas. Still, it's a tough sell to go to a rancher and say, we're not sure this is going to work, but we'd like to use your herd to see if it works. So it's a good thing that Kevin took an agent-based modeling course from Randy Boone and learned about this computer modeling tool, agent-based modeling, which is a bottom-up simulation where you can kind of program the behavior of individual agents. And so this video is showing the agents. Here are the vehicles moving through different traffic patterns as they were coded by the programmer in this simulation model. The other nice thing about these models, they're spatially explicit and really good for modeling complex systems. So if you can model cars and pickups and buses and things like that, why can't you model domestic cattle? So that's exactly what Kevin did, is he developed some agent-based models of cattle grazing in larkspur habitat. So the first model he ran, what he did was go out to the Maxwell Ranch and bring one of the pastures from the Maxwell Ranch into his model. And so he had remotely sensed data along with a lot of field sampling where they quantified the actual distribution and abundance of larkspur, shown here in the light purple color, and then used the imagery and field sampling to get a pretty good distribution of forage, the green, in pasture 16. And then he programmed his digital cattle, these little black specks, to either be real dispersed and spread out, or higher stock density in groups that stayed close together, so high herd cohesion and higher stock densities, and started looking at the occurrence of death loss in the computerized cattle. And what we found was that high stock densities and cohesive herds had very little death loss to larkspur poisoning, but as you get more dispersed herds and lower stock densities, the incidence of death loss went up and up. Okay, so that was pretty cool. And then the next model that he built was to change the landscape and basically answer the question of, you know, does patchy larkspur kill more cattle than randomly or evenly distributed larkspur throughout a large area? And so in this one, he didn't use, well, he started out with the total amount of larkspur in that pasture 16 he held constant, but he distributed it differently throughout the pasture in patches and how it overlapped with forage. And what I'm showing you here is just the patchiness results. So patchiness increases as the x-axis increases. So on the right is patchy larkspur, on the left it's spread out evenly throughout pasture 16. The left panel there is showing you no deaths, and then on the y-axis you're looking at the variation of individual intake of the toxins. Okay, so on the left you've got the occurrence of no deaths, and you can see that those are concentrated where the variance of intake is small. So everybody's getting some of the alkaloids and nobody's getting too much. If you now switch to the right panel, that's showing you the deaths. And so as patchiness increases and the variance
of intake goes up, you're getting more and more cattle deaths. And so what was really cool is when we then went to the next step and asked, does increased stock density and tighter herds, will that protect them even against the most dangerous larkspur? The answer was yes. And so on the left here we have results for cohesive herds, on the right dispersed herds. On the y-axis we're looking at individual intake of alkaloids. This 4,000 milligrams is kind of a critical threshold of intake above which you can start expecting a lot more cattle deaths. The width of each one of these, they look like Hershey Kisses, some tall and skinny and some shorter and fatter, gives you an idea of how many animals were consuming a given level of the alkaloids. And so back on this side, where you have dispersed herds, the majority of animals are getting no alkaloids, but you have enough that are exceeding that critical level that you're getting deaths. If you look at the opposite end of the spectrum in real cohesive herds, you don't have that many that are not getting any of the alkaloids at all. You're getting the bulk of the animals that are getting some, but nobody gets too much. So even with the most dangerous patchy larkspur, these tighter herds and increased stock density seems to be protecting animals from death loss. Okay, so in addition to those two computer simulations with the agent-based modeling, Kevin also did a field study where he wanted to see, all right, so by this point it looks like it may be possible to manage grazing in a way that larkspur can be grazed and we don't have huge problems with cattle death loss. Then the next question is, what does that do to the plants? And so he did a clipping study in the field where either 25 or 75% of above ground mass was removed by clipping 2 years in a row. And then of course we had an unclipped control, and we looked at the response of the plants in terms of above ground mass, the concentration of the alkaloids, and then alkaloid pools, which is the mass times the concentration. And what we found was that, you know, there was an indication of something going on with mass here, but not significant, not a significant reduction. I'll tell you more about that in just a second. But alkaloid concentrations did go down in both of our clipped treatments relative to the unclipped controls. And then by multiplying mass and concentration together, the 75% above ground mass removal appeared to reduce the alkaloid pools. So we might be making larkspur less dangerous if we can have some above ground mass removal. So these are Kevin's graphs of what he calls the year-on-year results, and so everything's kind of indexed to the 2016 values. So the 100% is what was there in 2016. Again, we have mass, concentration, alkaloid pools, and what you see here is even with our unclipped controls, mass declined a lot from 2016 to 2017. What we think was we had some high precip years that led to some really big plants, and the return to normal precip, smaller plants happening in 2016 and 2017. So that probably masked anything that might have happened with clipping and mass. Concentrations didn't respond too much in the first year, but then from year 2 to year 3, that's where we see those declining, and then a little bit more moderated response in terms of alkaloid pools. So this project was really made possible by that constant interaction with Joel. Kevin would program the cattle to act like cattle, and he was a cattle producer before coming here, but then he wanted to go to Joel and say, do these cattle act like your cattle do in pasture 16? And so we had that involvement with Joel kind of throughout. But what we're thinking now is that maybe avoiding larkspur makes it more dangerous, that top growth removal may actually make larkspur less dangerous, and based on those clipping studies and being a little bit cautious, we might get a 50% reduction in alkaloid pools even just after a few years of moderate top growth removal. And so we're encouraged by this, but what I mean by we're still cautious is that we're not going out and trying to convince ranchers to start doing this. Rather, we expect to talk to them more, find out more about their situation, but I'm pretty comfortable if a rancher comes to one of us after hearing this and thinks it might fit their operation and wants to ask the question of how could we maximize our chances of success, I think we have some valuable information to share with them. Yeah, I'm not to the point where I want to go and convince them to do that. We have another year on the project, and the last thing that we are planning to do with this is to reach out to producers who are in larkspur affected areas and start getting more information about their situation and their thoughts on the work so far. So that's the poisonous plants and livestock grazing that Kevin's been working on. Now we'll shift gears a little bit and talk about this new herbicide indaziflam on cheatgrass for restoring native sagebrush grasslands. So Jake Korkamp is a PhD student working on this with me. I've listed a bunch. I probably haven't got all of our end users and cooperators on this project up here and included some of the logos. But Dave Cottle is probably our primary cooperator. This research is funded mostly by the Forest Service, Bridger Teton National Forest. Julie Kraft, Sublette County Weed and Pest, has been contributing funding as well. And both Dave and Julie have been part of the design of this study from the get-go. And Julie, along with a whole bunch of folks from the Wyoming Game and Fish, sometimes the NRCS, which I neglected to put up there, will come out and help us collect field data. And then the work was really started by the folks in the weed lab here at CSU, especially Scott Nissen and some of the graduate students working with Scott. And we've had great participation and support by Bayer, who produces indaziflam. So I really can't stress the importance of our cooperators when it comes time for field data collection. They show up, this huge team. The Game and Fish, I can't even tell you how many people the Game and Fish sends to help us collect our data. Julie comes out, Dave comes out, we've had Karen Claus from the NRCS a few times, and then some of us from CSU go up there. And in addition to just collecting the data, then we have that many more eyes and that many more brains thinking about how we set this up, what we're seeing, why we're seeing what we're seeing, and how it applies to their needs and our interests in terms of research. So it's been a great, great partnership, and I think this one maybe even a step closer to actually being usable science the way that article talked about it. So a little bit of background on this herbicide, indaziflam, known as Esplanade. It is a pre-emergent herbicide, and it inhibits cellulose biosynthesis, and it's very active at the developing root tip. And so the way indaziflam works, it needs to get down to the soil and into the soil just enough so that seedling roots are growing down through it. Plants can grow up through indaziflam just fine, but the roots going down through it is where they suffer. So it can end up providing extended periods of activity because it's not very soluble in water, so it pretty much stays put. And what folks in the weeds lab and here and elsewhere have been finding is that you can get 3 to 5 years of control from one application, and application rates are actually pretty low. So pretty darn selective against seedlings of invasive annual grasses. The importance of the seed bank is demonstrated by this picture where the folks did a study where they did repeat Roundup applications, so non-selective herbicide that works by contacting the leaves of growing plants. So they have the control up here. Here's the amount of seedling abundance that showed up after 1 year of glyphosate application, and this is mostly cheatgrass and field brome, so annual brome seedlings. Maybe getting a little bit thinner after 2 subsequent years of glyphosate application, a little bit thinner after 3 years, but boy, if you get out to year 4 and 5, then you start to see no more cheatgrass germination from those sites, indicating that maybe the cheatgrass seed bank has been depleted. And so that's where indaziflam shows a lot of promise, because instead of having to apply it every year, if you're getting 3 to 5 years of control out of one application, what we're thinking is at worst, you would need to make 2 applications to get to that, 4 to 5 years of control, and then maybe the other plants can take over and regain dominance of the site. So we set up this project, again with the help of the Forest Service out of Pinedale, Wyoming, the Sublette County Weed and Pest, and this is now Jake's baby. Our first objective was kind of focused on these small plots and ground applications with a backpack sprayer, where we've got 4 replicates of these treatments. So we have our untreated control, 3 rates of this esplanade, and 1 rate of plateau. And the reason we decided on this one is this is what folks in the area are using and have had the best luck with. And then we went and talked to Bayer and our partners there locally and came up with these other treatments of esplanade. And just for your interest, right here we have one of the esplanade plots next to an untreated control right there. So these are replicated 4 times, and we're really looking at, are we getting cheatgrass control without affecting the other native plants that are established in there. And so what Jake's been finding here is, well, there's a couple of things. I'm gonna buzz through these results. Basically, in the first year, which would be the brown in this slide, or maroon, however it looks to you, we're not getting too much happening there. We've got plateau in year 1, did pretty well, but our other treatments hadn't kicked in yet. By year 2, we're losing some of the effects of plateau, but we had a reduction in cheatgrass cover even in our control that year, so that's probably masking what's going on. At our other sites, we've got 2 sites. Half Moon is on Wyoming Game and Fish. Boulder is on the Forest Service property. Real clear reduction from plateau in year 1. We're losing it with plateau in year 2, and the indaziflam hasn't really kicked in yet. If we look at density, because this is cover, so this is canopy cover, aerial cover. If we look at density, we're starting to see a little bit more reduction in terms of density than we were in cover. And this matches our field observations because even though the density was lower, the remaining plants of cheatgrass grew bigger. And so we got less of a change in cover than we did in density. But still nothing too outstanding yet, but that's okay because we're thinking it took that first year before indaziflam made it down to the soil. Because it only works on the seedling root tips, the stuff that had already germinated before the application went ahead and grew and produced seeds. So we're looking forward to years 3 and 4 to see where this kicks in. In terms of the established natives, I just included data here for the perennial grasses. They were basically unaffected or increased a little bit in the areas where we treated cheatgrass. Okay, so the first objective was really looking at those small plots, and then what our partners told us, the end users, was if we're going to use this in real life, it's not going to be a backpack sprayer and people walking around on the ground. We have lots of cheatgrass, so we really need to see what happens with large-scale applications, and so we set up an objective to use applications made aerially by helicopter in large plots that are about 2 hectares each. Because of that, we couldn't test all those different rates. We just picked 1 rate of indaziflam and had 4 replicated aerial treated plots and then compared that to the untreated areas in between those plots. So again, it's still pretty early in terms of the data on the responses. But I'll point out this great picture over here. There's 2 people standing right here. Those folks are in one of the aerial plots. And then this, what you're seeing in the foreground, all that little bit purplish, maroonish, straw-colored stuff is cheatgrass in some of the area between aerial plots. Okay, so what we have so far is that in both 2017 and 2018, we were getting reductions in cheatgrass cover. I didn't bring the density data for these. So we are knocking cheatgrass back, starting pretty early after application. The applications were made in 2016. And then our co-occurring or established native plants are doing just fine. Again, either unaffected or increasing by treatment. So things are looking pretty good in those aerial plots. Okay, so at this point, we're comfortable saying that Plateau, that herbicide that they're using now and they've been using for a long time, kind of did better in the first year after application than Esplanade. But then by year 2, Esplanade was starting to look better, Plateau was starting to look a little bit worse, which tracks with the work that folks have done with these two. And that our established natives were either unaffected or increased as a result of treatment. So in those big plots, they are grossly undersampled because we're putting like 6 quadrats or maybe even 5 in those big plots. And if you notice, the only natives that we could say anything about were our dominants. And we're really interested in getting some information on the less dominant species in this plant community. And so Jake is in the process of ramping up our sampling effort to begin this summer with some modified Whitaker plots to get more data on species that are there but are much less abundant than our dominants, to see if, if we can still say it looks like we're not affecting the native plant community. And then we'll keep on sampling kind of the way we have been for the other responses. Okay, so this has been pretty fun, and it's great having the end users with us almost every time we're out in the field to scratch our heads and think about what's going on and why and how we might improve. And we've actually been talking about adding some more plots because our Forest Service partner wants to see aerial plots of the Plateau and the Indaziflam together. So we might add a dimension to Jake smiling to the study. All right, let's move into wetlands and trampling wetlands with cattle. That's overstating what we're really doing, right? We actually did a lot of trampling with high school students. More on that to come. So yellow flag iris, Iris pseudochorus, is another exotic invasive plant, and it does really well in wetlands. This is Alex's baby, her master's research, working with me. Jordan Spock, who's now with the National Park Service, conducted his master's on yellow flag, and a lot of that work kind of led to what Alex is working on now. We've got James Hill from Agate Fossil Beds in the Panhandle of Nebraska, and then Rita Beard. Some of you might have known Rita. She was Jordan's predecessor, and she was actually still alive and working in the Park Service, and the main catalyst that got this project started, that was Jordan's master's and then became Alex's. There's a local weed partnership, the Pride Weed Partnership in the Panhandle of Nebraska, that has supported this research very well. So the 2 major funders of this project are the National Park Service and the Pride Weed Co-op. Sioux County, the county weed program there, has been hugely supportive, as have the FFA students from Harrison High School. So we'll talk about some more of that. And this picture here is taken in Agate Fossil Beds at the Niobrara River. And so that really narrow, really deep channel you see going through there is the Niobrara. And part of the reason it's so narrow and deep is because of the yellow flag iris that's encroaching. So this is a rhizomatous perennial, and the rhizomatous mats are impressive. If well, show of hands, how many folks have walked around in cattails in wetlands? Okay, you'll get this. So you're walking around in cattails, you're never quite sure if it's going to hold you up, right? At any step, you might just go down, through. It's kind of squishy. I hope Alex doesn't do this. I've I've made this claim, and she's probably going to hold me to it one of these days, but I'm convinced you can put a blindfold on me and set me out walking across the wetland along the Niobrara, and I could tell you if I'm on cattail or yellow flag iris just by how it feels. Yellow flag rhizomatous mat feels like this floor. Other than the holes, there's no worry about falling through. And as soon as you step on cattail, it's that squishy, oh my gosh, next step going to be okay? Okay, so it's an impressive rhizomatous mat. In addition to that vigorous vegetative reproduction, vegetative spread, this yellow flag iris can produce a lot of seeds that float downstream, find a place, germinate, and establish. And so it's very aggressive. It's big, can be up to 2 meters tall, non-native to here. So a lot of our work, it all started at agate fossil beds, and ever since then we've been, especially Alex, been finding yellow flag, even here in Fort Collins. She's been calling the city, and Jordan saw it up close to Rocky Mountain National Park, and somebody else said it was over by Greeley, so we're finding it everywhere. But it all started, our research, not the infestations, I don't think, but our research all started at agate fossil beds in the panhandle of Nebraska. So in the beginning, when Jordan started his project, by talking to the local folks, the end users, they had told us that we've got this herbicide treatment, imazapyr, which works pretty well. But imazapyr has restrictions on it when it comes to diversions, irrigation diversions after application. And so we found a study from Eastern Washington that also looked at the aquatic label Roundup, or glyphosate, and that suggested that glyphosate was a pretty close second. It worked pretty well. And there's no restrictions on irrigation diversions with glyphosate. And so we thought, well, let's focus on glyphosate and see if we can improve its effectiveness by adding another stressor to the plant, and that was a cutting treatment. So we really started out looking at herbicide, which is glyphosate, and cutting. You can see in the picture on the right here to see if we could reduce the density and height of yellow flag iris. Epic fail. We just made yellow flag iris mad. But interestingly, early on it looked pretty good. And we ended up talking to the folks in Washington who said that glyphosate was actually pretty good. They said, yeah, we let that go too early. The next year after we put that little report out, our glyphosate treatment started looking really bad, more like what you folks saw. So anyway, it wasn't a total loss, because what Jordan observed were these trails around our plots. So in the first year of the study, we had been out there collecting data from these plots about 4 times in the growing season. And by late summer, early fall, what used to be dense iris turned into this beaten trail where no iris was growing. And so then we thought back, agate fossil beds hasn't had any kind of large animal, grazing animal in it for over 40 years. Ranches upstream of agate and downstream of agate that were actively grazed by cattle, yes, had some yellow flag iris, but not near as much, not this continuous band all the way through the monument. And we thought, wow, there's something to this trampling idea. So that's where we called on Harrison High School FFA, because we couldn't get cattle into the National Monument, at least not quick enough for our needs. So we had students come out, get equipped with waders, and we ended up trampling about half of our plots and then leaving the other half untrampled. And so after 2 to 3 minutes of, 2 to 4 high school students trampling a plot, there's what it looked like. And when we looked at the impact of it, we saw a pretty significant impact of high school student trampling on yellow flag iris density and height both. And so pictured there with the results are our tramplers from high school, plus some of the Sioux County weed folks and a couple of Park Service individuals. So this was pretty promising. In addition to these promising results that were part of Jordan's thesis, there was an observation that trampling seemed to be more effective where plots looked like this when trampling occurred. So we actually had some outliers in the data set that were kind of high and dry plots where we didn't have standing water when it was trampled. And so we thought, wow, maybe there's something with this saturation and trampling together. And Alex really developed that into what's become her master's project. Again, you know, after working with the folks on the ground, the end users of this. And she really wants to determine the extent to which trampling early or late, so timing of trampling and saturation influence both the density and height of yellow flag iris. And so she hypothesized that trampling, regardless of saturation, was going to reduce both, but that the effects would be more pronounced when the plants were saturated than when they were unsaturated. And then early on, we thought that the early trampling was going to be more damaging to the yellow flag iris than the later trampling. So Alex went out, collected a whole bunch of chunks of rhizome, brought them back to the greenhouse for a greenhouse study, set it up with this treatment structure. It was basically a factorial, so 2x3 factorial of all these different options. We had saturated and unsaturated that were either untrampled, trampled early when leaves were about 15 centimeters tall, or trampled late when they were a little bit taller. And then her responses were height and density of yellow flag iris. And so what we found was pretty obvious, that saturation and trampling work together to impact yellow flag iris. Okay, so our notations here, the first letter U or S stands for either unsaturated or saturated, and then the T sub whatever is the trampling treatment, early, late, or untrampled. And so here are saturated, early, and late, both really knocked back the yellow flag iris in terms of its height and its density. And so when Alex went through to summarize her hypotheses, we kind of have a split decision on the first one, because we did get a decrease in both density and height, but only where we had saturation. In the unsaturated ones, we didn't see much effect of trampling at all. But her second hypothesis, that the effects under saturation would be more pronounced, that was a keeper. But we had no difference between the early and the late trampling treatments. So where is Alex headed now? She is starting a study to look at carbohydrate levels in these plants to see how that might be related to the plant responses to trampling and saturation. So that's starting up right now. So we get a little bit better idea if these plants are just croaking because there's no oxygen, or because they're depleting carbohydrates and can no longer grow. Alex also has a field study, and this is where there's been a lot of cooperation, communication, interaction between one of our end users, a rancher just downstream of agate fossil bed, and us. And so we, especially me, I think Alex humored me, but was like, I want to trample it with cattle. And so we went to the Skavdal Ranch, and Charlie Skavdal said, yep, let's do it. And so we have about, is it 7 of these exclosures, Alex, in one of his pastures. And you can see the ungrazed, untrampled iris inside of there compared to the trampled area outside. But this has been a learning curve for us, because especially with what we've learned about saturation, we're thinking that the cattle needed to be in there much earlier in the spring than our end user wanted to make happen. And so that's kind of a, it's an important lesson for us. It's maybe an indication that trampling with cattle might not be the best thing to do, as badly as I want to do it. I just want to be able to say we improved wetlands by trampling them with cattle. But there are other ways we could get top growth impact if we can't make it happen with domestic livestock. So I want to leave some time for questions here. I think this has been like a fire hose. I've been just burning through a lot of stuff. It's fun, but I want to leave time for some questions. So this idea of usable science, going back to what I highlighted here, is probably the real important part of usable science, and reflecting on these 3 projects that have been going for different lengths of time, but long enough to know that it seems like the individual iterations of that, so the individual graduate student projects, it's harder to reach that usable science goal within one of those individual efforts. But when we start stringing 2 or 3 together, and it may be just the time that we have to interact, get to know each other, share ideas, that usable science target seems to become more and more possible. And it also helps because, you know, we've had some of those early projects that didn't yield much in terms of usable results, no effects, but then they, you know, helped us on the next step of the project to really do some, I think, neat stuff. So with that, I'd be happy to answer some questions that you might have. Mark.
Question and a comment. So first the question, do you have any hypotheses as to why clipping would increase alkaloid content in the larkspur?
Decrease alkaloid. Decrease. Yeah. So what we think, Kevin's really looked hard at the literature, and it's pretty well established that there's a cycle of alkaloid production and movement in the plant, that they're produced in the roots, they're moved above ground during the growing season, and then moved back below ground in the dormant season. And alkaloid production is constitutive. It's just always happening. And we haven't been able to link it. I haven't done the work, but people that have done the work, mostly the Poisonous Plants Lab, haven't been able to link it to environmental factors. It just seems like these alkaloids are always being produced. So if they're above ground, and they're nitrogen expensive, and so that would probably, well, that leads me to believe that the plants are recycling them for a reason. But anyway, they're always producing them. If they're above ground in the growing season and removed, then you're taking away basically from their alkaloid savings account. So there's less to move back down, and their content is more reliant on that continuous production. That's what we're thinking. And a comment.
Nice metric.
Which one?
Metric system.
Oh, I almost changed acres and ounces for you. I thought of that 2 days ago, and I thought, no. No. My end users talk in acres and ounces. Thanks. Anna Claire.
Along the same lines, I was wondering if you thought, you know, I like working with cattle on the ground too. So in Kevin's metric about the same thing about the mass and the alkaloid with clipping, like the simulation of grazing, basically. I wonder what the effect of the trampling in addition to the grazing, the herbivory, if that would even augment those changes.
It could. So the question, I'll summarize it, tell me if I missed it, but basically, could trampling plus grazing have more of an impact on larkspur than just the grazing alone? Mm-hmm. It could if trampling is happening. There's some pretty decent data out of Burns, Oregon that suggests that on cattle, that cattle try really hard not to step on bunch grasses and like identifiable plants. So when it gets to, you know, real dense vegetation, especially if it's rhizomatous, it's hard to miss it. But if there are, and larkspur is kind of clumpy, if you will, kind of like a bunch grass. So I would say if they're stepping on it, it might be an additional impact, but there's a decent chance that they're not stepping on it very often. Good thought. Let's see, who first? Alex, and then Dan. Okay, Dan, then Alex. Either way.
With the yellow iris study, I was wondering, why didn't Rancho want to do the cattle trampling thing earlier in the season?
I don't know exactly, Alex. I mean, I'll repeat it for the camera as well. So basically, why didn't the rancher want to trample earlier in your field study?
His was mostly a preference as to what pastures he likes to use during what year. He has a pretty solid routine that he runs in, and the vegetation in that area too is different that time of year, and what's growing what isn't as opposed to later in here. So it just kind of, it's more of a hassle for him to get them in there and then have to push them to a completely different part of his property off schedule was kind of his big thing.
Good question. Good answer. Thanks. I feel like the moderator.
I had a yellow flag question too. So the results showed like huge reductions in yellow flag with saturated trampling. And I was wondering if you guys had come up with a working theory as to why that might be, why the presence of water or soil saturation is going to have such a huge impact.
Well, where to start? Oh, so I'll start here. So, okay, repeating the question. Why do we think trampling under saturated conditions had such a big impact? So what is it about saturation? So wetland plants, in order to survive in saturated soils, saturated conditions, they have to have some adaptation to get oxygen from above the water level down to cells in the roots. And so aerated tissue often in the shoots, and I think for yellow flag iris, that's their only source of oxygen, is critical. And so basically if you break that snorkel, they can no longer get oxygen from above, and that alone might be the impact. And then that's why we're moving into the carbohydrate work, is to see if, if we're seeing a change in carbohydrate reserves. Basically, are they just depleted and can't grow back, or was it something else? Not bad? Okay. Yeah?
I thought about in Indazaplan, and so you're looking at the perennial bunch grasses that are dominant and looking at the how those are impacted. Would Indazaplan also impact the seedlings of those native plants as well, or is it very specific to the roots of those annual grasses?
I think it would affect the seedlings of those native perennials as well. Yeah. And so that's probably a future study. We started out in this one saying we just want to look at established perennials. We got kind of interested in there's a small number of small forbs and 1 or 2 annuals that we run into up there. And that's one of the reasons we're ramping up the sampling, to see if we can see anything there. But we haven't noticed any seedlings of the native perennials. So I don't know if it'd be worth looking for them there, or if we'd have to do something to cause there to be seedlings of the natives. But my hope and my gut feeling is that we could go, even if it was 10 years, without seedlings of those, and I'm looking right at Mark because I'm sure he's going to jump on me, but without seedlings of those native perennial grasses, if we could get rid of cheatgrass. That's my hope and my gut feeling. But
just because the thought on that, it's like if you're so actively selecting against those native plants, you're both selecting against the native or those invasives, but also against any potential native annuals as well. So
yep.
Pushing that community in a different state. So just a
yep. Yep, it's on our radar screen, but we don't have anything on it about it yet. Anything to add, Jake?
No, I mean, anything that makes cellulose has the potential to be affected in that very top layer of soil. So I think the null hypothesis has to be that, right, anything that's trying to germinate in that top little layers potentially has the potential to be affected by indazaplan.
And that's a good additional point, is that, because indazaplam doesn't move very deep into the soil, if your natives are germinating deeper, they can be expected to grow up through it fine. But if they're in that zone and the roots are going down through it, I wouldn't expect them to survive. Anna Claire.
In regards to Jake's study too, what method were y'all using in the quadrat that wasn't capturing the less dominant species, and then what method or metric are you thinking to change to switch to?
You want that one?
So mainly the point is that we're not sampling a big enough area to really get a significant sample of a plant that is just rare. just because it's rare. So what we're trying to do is we're just adding more, and we're just going to sample more area next year.
What are you measuring in your project? Are you measuring composition or are you measuring?
Well, we measure cover and then also frequency,
Okay.
just whether it's there or not.
But the main thing, so we're estimating aerial cover, all above ground parts, using extended Daubenmeier frames. And so when I said, we only had 5 quadrats per big aerial plot, each one of those quadrats is half of a square meter. So we're not sampling much. It's fine for the small plots. And so what Jake's moving to sample more area is a variable size plot method. It's the modified Whitaker approach. So you have a bunch of different quadrat sizes, and then you can get a better idea how much of the plant community you're able to quantify with that approach. Sonia.
One of your early questions when you were talking about the larkspur study was, Joel was wondering, would there be certain seasons maybe that would have less alkaloids in the larkspur? And it seemed like with your results that the alkaloids declined in the non-treatment plot as well.
Mm-hmm.
Do you have any idea of why that was?
Not really. It does happen. There are low alkaloid years and high alkaloid years in larkspur, not just Geyer larkspur, but the other ones as well. I'm not sure what drives it. Not sure. But we did, from 2 years of data, we looked at alkaloid concentrations early, so before there was anything but basal leaves, so before the plant bolted, and then right when the plant bolted, and then again in flower. And based on that, we have some evidence that we might be able to identify low alkaloid years pretty early on. But we just got, that got us thinking, and we just went off on a different route from that point. And Joel hadn't come back and said, well, where's the answer? Yet. Okay, I'm getting the sign. Thank you, folks. Appreciate it.